different this unit. We're not talking about those quadratics and stuff anymore. We're kind of moving past that. We don't want to forget that we did all those things because those are important, but we're moving on from it. We're doing something different. So we're going to start out with 9.0. There's 2 9.0 lessons. You will take a quiz at the end of the week, a really short quiz. This stuff is like very straightforward. You'll see what we're doing here. What we have done so far when we're talking about our 2 topics for today, which are domain and range, so far we have always been talking about domain and range using the notation where, do you remember we did range where it was like y is greater than or equal to 4, right? Inequality notation, that's what we've been using. We are going to now learn a different kind of notation to say the same thing. This new notation is called interval notation. It's kind of a higher level of notation that you're going to see as we get higher and higher into like our math classes. You'll start to see this notation more often. Intervals are used to identify the possible values that a variable can be equal to. So basically, we're going to give it like a bottom number and a top number, the minimum and the maximum, and then everything in between is what that variable can be equal to. We have some important interval notation rules. I would recommend you highlight these boxes. This is going to be important information right in here. We have 2 different ways that we can write interval notation. The first is using these square brackets. We use square brackets when the variable can be equal to the number value. Brackets are what we call inclusive. I'm going to compare our interval notation that we're learning to something that we're familiar with. Do you remember when we did inequalities and stuff like that? We used greater than or equal to or less than or equal to. It's the same thing. Brackets, the equal sign, if we think about things on a number line, which we're going to talk about in a second, that's like our filled in circle. Okay, it includes that number. On the other hand, the opposite of a bracket is a parenthesis. We use when the variable cannot be equal to the value, but approaches the value. Parentheses are exclusive. So when I think about using parentheses, I'm usually thinking about greater than, less than, without the equal signs, or on a number line, I'm thinking about that open circle. And then a weird little tidbit that we get when we're talking about interval notation, oftentimes we're going to see infinity symbols. Because a variable cannot actually ever be equal to infinity, because we can't ever reach it, every time we use an infinity symbol, we will be using a parenthesis. So that's just like a good rule for any time we use infinity. So I'm going to show you what this looks like. It's really not super complicated here. We're going to use interval notation to represent the number line. Our interval notation should always go from the least to the greatest. So on a number line, the smallest number is going to be on the left. I can see that this number is a -2 right here. And then do we see how that circle is filled in? That means it includes -2. If I am including -2, I want to use a bracket. Make sure your bracket is clear. I can clearly tell that that is a bracket and not a parenthesis. I am not going to be guessing when I look at your work. So if I can't tell, it's going to get marked off. That's the least. Now I think about what's the greatest this goes to. A lot of the times we're going to see arrows. This arrow pointing to the right means it goes on forever and ever and ever in that direction, which means as it gets bigger, it's going to get closer and closer to infinity. So this says I start at -2 and I go on to infinity. Anytime we use an infinity symbol, we will partner that with a parenthesis. And that's interval notation. That says that that variable that's represented in that number line is somewhere between -2 and infinity, and it can include -2. Any questions on that? Now, while we have infinity in the positive direction, as numbers get bigger and bigger, they reach infinity. But we see this arrow in letter B is pointing to the left. It's pointing more and more negative. So we also have something called negative infinity. As numbers get smaller and smaller and smaller forever and ever, they approach negative infinity. So the smallest number, technically, that this interval notation is going to start at is a negative infinity. We're going to partner that with a parenthesis, of course. And then I'm going to figure out what's the biggest number that this can reach. And I see that we're stopping at 0. And then that's an open circle. So what do you think? We're going to have a bracket or a parenthesis? Parenthesis. Perfect, because we're not including that 0. So these look like coordinate points, right? We've got a bottom number, we have a top number, there's a comma in the middle. They look like coordinates. They're not coordinates. This is interval notation. Letter C is a little bit weird. Okay, what's the bottom number that I'm looking at here? What's the lowest this goes? James? Perfect. What's the highest this goes? Positive infinity. So the interval notation here, when it encompasses the entire graph, is negative infinity to positive infinity, both with parentheses, because we always use parentheses for infinity. Questions on that? That's what the first part of your homework is going to look like, so we just need to know how to look at those number lines and pick those numbers out. What we're going to focus on is that we can also use interval notation to describe domain and range. We've talked about domain and range before, especially last unit when we talked about the parabolas. We're going to continue talking about them, not only with parabolas, but also with other kinds of shapes of graphs too. As a little refresher, remember that domain represents all the possible x values. X goes left to right, so the domain literally tells us how far is it restricted from left to right. And that order there is also kind of important. That order, left to right, is also the order that we're going to be writing our interval notation in. And then as a refresher about range, range is all the possible y values. And y goes up and down. So it's literally telling us how our graph is restricted. Again, order is going to matter here, from bottom to top. Any questions about domain and range before we really get into it? Okay, flip it over. Letter A is a parabola. That's what we talked about all last unit. Does anybody remember what we used to say for the domain of a parabola? We're going to start with domain. James? We used to say all real numbers. We cannot say all real numbers when we're doing interval notation. We're going to use interval notation to represent all real numbers. This unit is very visual, so I'm going to be drawing on the side to kind of show a number line of sorts, so follow along with me a little bit. I'm going to see how far left or right does this parabola go. We know it's going to keep going outwards forever and ever. It never is going to come back in. So I'm going to say it goes to the left all the way towards negative infinity, and it goes to the right all the way towards positive infinity. So my domain is everything in between negative infinity to positive infinity. That's how far left and right it goes. Everybody with me on that? Okay, now I'm going to talk about range. And when I start talking about restrictions here, I'm going to start drawing in like walls to show where the lowest it can go, where the highest it can go is. So the lowest, because I always want to start least to greatest, yeah. The lowest it can go is 0. Does it actually touch 0 on my graph? Yeah. So we want to include 0 in my interval notation. So I'm going to use, when I want to include something, I'm going to use a bracket. Now, how far up does this go? It goes all the way up to infinity. So this is from 0 to infinity, and anytime we use infinity, we're using that parenthesis. Everybody good with that? So just as a refresher, left to right, range is always bottom to top. If you do not write it in that order, bottom to top or left to right, you will not be writing it in order from least to greatest, and your interval will be wrong. So that is super important that we're writing from least to greatest. Good? We're going to do some more examples. Okay, here's a wonky looking graph in letter B. I'm doing the same thing. I'm going to start drawing some walls, some restrictions. How far left can I go? How far right can I go? So starting with domain, the furthest point left that this graph touches is what? -4. Do we include -4 in our interval? Yes or no? Well, okay, -4 is here, but is it going to get a bracket or a parenthesis? Is it included? It's going to get a parenthesis. Why does it get a parenthesis?
Because it's included. I don't know.
It's not included. What tells me in this picture that it's not included, Cody? The circle is open. So because that circle is open, it's getting a parenthesis. It never actually touches -4. And then it goes this way. What's the restriction on the right? Does it have an ending? So what do I write when it has no ending? Infinity. So this, goes on to infinity. And again, a parenthesis. Perfect. I'm going to do the same thing for the range. I'm going to start with the bottom number. The bottom number here is what? -5. Does it ever actually touch -5?
Yeah. No, it doesn't.
It doesn't. Why not? The circle's still open. It's that same open circle we're looking at. So I've got an open circle, which means anytime I have an open circle, I'm looking at a parenthesis. And then what about the top? It's the highest this goes. Cody? Yeah, to 3. Does it actually touch 3?
Yeah.
It does. It touches at 3. So we are going from -5 to 3. And at 3, we want to bracket. Good? Making sense? Okay, keep going. I think letter C is a super interesting one, so definitely one that we want to talk about, I think. What's the domain here? Anybody want to give it a go? Jaden? -infinity to +infinity. These arrows are pointing left and right. So I'm going from -infinity to +infinity. Perfect. What about the range? Anybody want to give that one a go? It's the lowest point on this graph. Yeah? Perfect. -infinity. This is going downwards to -infinity. Well, how far up does it go? +infinity, right? So just because those lines are like only drawn until this point -5, we see that arrow is pointing downwards. It's going to keep going past that. Oh, sorry, -3, I guess. So this is also -infinity to +infinity. Good? Okay. Couple more, then I'll be done. Anybody want to try letter D? What do we think for the domain for letter D? Jaden?
Infinity or -infinity to then
Perfect. So I see that arrow's pointing to the left. That means we're starting at -infinity. It's going until we hit 2. It stops at 2. 2 is an open circle, so we know that we're not going to include 2. So this interval is going to look like -infinity all the way to 2 with a parenthesis because of that open circle. Good? Anybody want to give range a go? Perfect. We're doing the same idea. The lowest point is at this -3. It's an open circle, and it goes all the way up to +infinity because of that arrow pointing upwards. So that's a -3 to +infinity. Questions on this one? I'm going to do one more. I'm going to skip the parabola because we already did a parabola, but I think F is a good one to look at. Let's do domain. What do we think about this domain? On the left, it starts at, is that going to be a bracket or a parenthesis? Now what about on the right? Goes on to infinity because of this arrow. Easy enough. What about the range? What's the lowest this graph goes? The lowest number that it touches. What's the highest number that it touches? So if it's only touching 3 ever, our range will just look like this. The number 3 in some brackets. That's maybe a weird one you want to star because that's a weird range, but there you go. Any other questions on this? Okay, I will be paying very close attention to those brackets and parentheses, so I better be able to tell the difference between the two in your